All right, good morning, everybody. We are going to get underway. My name is Cody Brewer, and I am the Business Development Manager here at Productive Plastics. And today I will also be joined by Samantha Stacy, the Technical Manager at SIMONA PMC. We're both really glad that you could all be here with us. So today we're going to talk about TPO and some of its advantages. We're going to give a little overview of what TPO is, how it stacks up against some other processes, things like metal or fiberglass. Talk a little bit about some of the grades of TPO available and how it can fit, what application you're looking for. And then we'll go through a couple of case studies, show you how we've used TPO on parts for our customers and what the advantages of those were. So Productive Plastics, we are a heavy gauge plastic thermoformer. We were founded in 1955, so we're coming up on 70 years of operation. We do all vacuum forming and pressure forming, in-house paint facilities. A lot of times in using pressure forming, we utilize textured molds to give a really good desired finished product. Now I want to introduce Samantha Stacy, who will tell you a little bit about SIMONA PMC, and then we will get into our presentation.
Great. Thanks, Cody. So Samantha Stacy, I'm the technical manager at SIMONA PMC. I've been with the company since about 2015. So came in as a process engineer and spent some time as quality manager, and now I'm in charge of technical, so R&D, giving presentations like this, and just helping our customers and OEMs pick out materials. So a little bit about SIMONA PMC, custom sheet extruder. We're in Findlay, Ohio, which you probably don't know where that is. It's about 45 minutes south of Toledo, if you're not familiar. We focus on the thermoforming market. So everything we make is as a flat sheet, ends up being thermoformed into another part. We have very few pieces that stay flat. We were previously a part of Romark. Some of you might be familiar with. Grew out of some excess capacity with Romark back in 2003, and heavy growth in 2016. Romark moved out, built a new building in the same industrial park as us, and we were acquired separately by SIMONA in 2018. So it's been a good purchase for us. We're with other sheet extruders. So we have 3 lines here in Findlay. They're all coax, so all multi-layer sheet extrusion. Capabilities up to 116 inches wide, up to 400 thousandths thick. The thinnest we go, which I'm getting asked about more and more, is like a 033 on TPO. Different capabilities, corona treatment, film lamination, and then we do have a small R&D line here as well for a lot of our innovation work or prototyping, small sheet runs. We have an in-house quality lab and a small thermoformer. So all of our customers thermoform these parts, and we want to make sure on the quality side, as well as the R&D side, that we are able to thermoform as well, mostly just to check and make sure what our customers are seeing is the quality that we're striving for. We are ISO certified, and we have currently 75 employees, although we are looking for more. So if you know anybody in Findlay looking for a job, send them our way. Sorry. Cody, you might have to help me out. Yeah. Thank you. Sorry, guys. It's my first webinar, so I am trying to figure it out still. So why TPO? What is it? TPO is thermoplastic polyolefin, which is sort of a generic name. It's a blend of polypropylene and polyethylene. There's some elastomer in there for impact, and then some minerals, talc, other additives, so UV, sometimes FR, etc., for different properties. It's processed a variety of ways, obviously extrusion, which is what we do here in Findlay, but it's also blow molded and then injection molded depending on the grade. I mean, you see a lot of TPO in automotive. A lot of that's injection molded. Most of your bumpers are TPO. So why choose it? There's 4 reasons that we see TPO being chosen over, at least over other plastic materials, as well as over fiberglass or a metal. The first and one of the major selling points, I think, is the cold temperature impact resistance. So it's ductile down to -30. So we see a lot of parts, you know, for these outdoor in the winter being moved to TPO for that impact resistance. It's going to dent before it cracks. Low thermal expansion, so parts that see a bunch of temperature swings, pretty chemical resistant, and then almost all of our grades are weatherable. So it holds up outside, inside, wherever it's being used. It can be multi-layer extruded. Like I said, all of our lines in Findlay are coax. So we see a lot of people choosing the core layers for properties, and then you add that cap layer for the aesthetics, whatever you're going after, high gloss, low gloss, whatever. So just kind of diving into some of those benefits. So the first one, like I said, this is a major selling point for TPO, cold temperature impact. You can see these samples. They were put down in a freezer at -30°C. You've got 2 different types of acrylic and then 2 different types of ABS compared to the TPO. You can see they've all cracked except for the TPO. It's definitely denting, but it's not full failure. So that's one of the major benefits. The second one, which has been more popular lately, is the Low CLTE. This is one of the major benefits for it over an HDPE product. So CLTE, what is it? It's coefficient of linear thermal expansion. So how much the part in total is moving from -30°C to 80°C. So not just cold, but hot temperatures. This is pretty important when you're looking at larger parts. Parts that have a long span, like you can see in the photo there, those bottom skirts for the U-Haul were moved to TPO because of what's happening in that top picture. They're warping in between the connection points. There's a ton of rivets down the side of that thing, and basically there's no room for the expansion and contraction of an HDPE. And so it's got to go somewhere, and it makes this bacon shape. So overall, TPO has 4 times less expansion than the high density polyethylene. So we see that a lot in flat panels or big kind of shoebox lid shapes. It has half that of ABS. So even if ABS is having a little bit of an issue, TPO is going to move less than that as well. And this is just some quick math. If you have a 4-foot long, let's say, panel, and it's in HDPE, your total contraction is over 1/2 inch either direction. So you have to account for over 1 inch of movement total. With ABS, you have a little over 1/2 inch total, and then a TPO is just a little bit over 1/4 of an inch. So that's pretty doable to account for. Benefit 3, solution to ABS stress cracking. So even if it doesn't crack because it's getting cold, we do get a lot of, mainly at attachment points with our acrylics and ABSs. That's what PMMA is, it's acrylic. Around where those attachment points, where there's some stress and where a lot of that contraction and expansion is taking place, it can cause some cracking just because of the stresses. TPO is used a lot to solve that issue. As you can see in that green part, you know, they have a big bolt attachment that was having some issues cracking. The back of that utility vehicle cracking just because of the shape. So anytime you're bolting together or restricting the movement of a part, TPO gets really popular to help with that. This is kind of a lot of a slide, but basically really good chemical resistance. The only thing that's really going to bother TPO is something oily. Think a diesel, think a kerosene, something of that nature. And only if it's really soaked in it, it just makes that rubber content, the elastomer in there, swell up a little. Not really too much of a property issue, more of a, discoloration type of issue. But for the most part, pretty good in chemical resistance. Again, this is a lot to look at, but weatherability, almost all of our grades have weatherability already, they have UV in them. Even in bright colors, which are traditionally hard to weather, your reds, oranges, yellows, those always have a little bit of an issue weathering no matter how much UV is in them. TPO, particularly the high gloss caps, perform very well in those outdoor service environments. Just a quick slide compared to a gel coat fiberglass. We looked at it in an orange color as well as a dark red. Typically, we use the automotive standards, indoor and outdoor SAE for accelerated weathering. Rule of thumb's about 1,000 hours is 1 year of South Florida exposure. And we looked at the fiberglass against the high gloss TPOs, and you can see the fiberglass is good to a point. About 1,000 hours, you get a 4 delta E. In that bright of an orange, you're going to start to be able to visually see differences around 3 delta E. So it's good for about a year, but after that, it dramatically starts to fail. You can see we did the same colors in orange and red and high gloss TPO, and they're still performing very well even after 2,000 hours, which is, it's 2 years South Florida exposure. And that's with water and as well as heat. So again, on the why TPO, one of the, I give a lot of these presentations, and one of the biggest topics that I'm asked to come in and talk about with our OEMs, with our thermoformers, is conversion. A lot of people looking, especially conversion out of fiberglass right now, just due to availability, but also out of metal, asking questions. People that have never looked at this type of conversion before are more interested now than ever. So slide kind of came out of that popular topic. One of the first things we talk about is lightweight, especially there's a lot of electric vehicles becoming popular. People are starting to look at lightweighting. How can they take some weight out of the finished product? Like I said, especially vehicles, also boats, those types of products. So about your typical thermoformed TPO part, it's about 6 times lighter than metal. So it definitely wins against metal for lightweight in that category. It's also about 30 to 40% lighter than the same part in fiberglass. So that's been a big deal. Fiberglass has always been a very labor-intensive process as well. You can make the same thermoform part with a lot less labor going into it. It's also an environmental control issue. I know fiberglass, obviously, anybody who's been to a fiberglass plant has smelled it a mile away. There's actually permitting required for that type of resin to be used once you get to a certain amount. Not true with thermoplastics. Shorter processing times is another big thing, especially again against fiberglass. So the fiberglass parts do take a long time. They may have slightly cheaper molds, but it's about an hour and a half to get one fiberglass part, and you're looking at 15 minutes with the total cooling cycle for TPO parts if you're thermoforming them. Big thing people talk about converting to metal is corrosion. Even if you paint it, the paint chips, and then it just starts this point for rust. So moving a lot of the claddings, the bumpers, the wheel flares to TPO to both prevent corrosion and cracking. Geometry is a big deal. More uniform wall thickness in a plastic than a fiberglass, usually a little bit tighter tolerances. And then with the metal, it's a lot easier to form a smooth curve in. So we see a lot of straight corners in metal that are really easy, but then when you start to add some of those curved design features, that's where it ends up being a little bit cheaper in plastic. Tooling requirements, one thermoforming mold is going to make a part every 15 minutes. Because it takes so much longer to make a fiberglass part, a lot of people have to use multiple tools. So you have multiple parts in process at once, and that starts to add cost. So we see that kind of being the cost benefit there. And then recyclability. We get asked a lot, what are we doing to, recycle material and utilize recycled materials, which is kind of a funny question because we've always depended on recycled materials. There's about 20 to 30% recycled content usually coming back from the former to go into the sheet. So that's not necessarily true for fiberglass or metal. This slide can be pretty quick. These are just some quick examples. Picture is 1,000 words, they say. So these are just some conversions to plastics from that metal or fiberglass that we've seen in the past. You can see that UPS truck, the gray pieces at the bottom. Again, that's a good example where TPO is a good option because it's a long flat panel. It's attached multiple places along that truck. So really to prevent that from warping. The front trunk bumper, that Mac bumper on the bottom left, that gray part becoming TPO. We've also seen a lot of these trailer end caps, so the white and black there in the bottom right corner. And those, again, it's for cracking. Cracking, denting, some of them were metal, they'd corrode, they cracked, the paint would fade. Switching them to ABS or an ASA type of product solved some of it, but then you've got, again, the stress cracking, the cold temperature cracking. So actually, I think that lower right one looks like it might have a little dent in it because it was metal. So a lot of those moving to the high gloss TPOs. So moving kind of out of the why TPO and into what are your options. PMC, we extrude 13 grades of TPO regularly. So we stock 13 around that grades. We have access to many more. So you have a lot of options. It can be a little bit overwhelming, especially coming from metal or fiberglass and not kind of knowing what the options are. So how I usually present this, I like to think of it as a menu. So based on what properties you're looking for, here's all of our grades. And then I start to, as I learn more about the application, it allows me to remove some of these choices. It narrows them down, narrows the field down, so it's not quite so overwhelming. So when we're talking about TPO, there's two main characteristics on the menu. So gloss is the big one. You want high gloss? Do you want low gloss? Or don't you care? So high gloss, it's half the options, about half the options are low gloss, kind of depending. We see a lot of low gloss in your interiors, heavy truck likes low gloss, a lot of your high gloss in your exterior panels, parts, think vehicles, tractors. They want it to look glossy and shiny on the lot. The other factor that we think about is melt strength, which is kind of an interesting one. Melt strength when TPO starts to sag in your thermoformer. You start to form this bag. It's not like ABS where it's slowly melting. Once it starts to sag, it sags. So how well do you need that to hold together? Why is that important? It kind of depends on your tool. How deep is it? How complex? The more complex a part, you might need a little melt strength to kind of help with that thermoforming just a little bit. We can go all the way up to a high stiffness material if that's a concern. So we kind of talk about aesthetics in that and how hard is this part going to be to form, how many features. So those are kind of how I see our world of TPOs. So just starting off, just the standard TPO series, 500, 600, and 700 series for PMC. So 500 is our utility grade, just, you know, it's a high regrind content. It's not going to have a lot of melt strength, but it's great for utility parts, for something simple, small. 600 and 700 series start to get into our standard and high melt strengths. So again, that's that melt strength factor. Any of these can be textured. They can be smooth. We have a set of stock textures. They can take a texture in a tool, and we see them a lot as core grades as well. So they could be co-extruded. We can put a high gloss cap over it, a low gloss cap, and whatever properties we're looking for. Regrind compatible. So you can kind of see how the flex mod moves. Your PMC 600 is a standard, looking at around 275 PSI flex mod, HDTs around 210. PMC 700 is probably one of the most popular grades. That's the high melt strength. You get a couple degrees on HDT, but you really gained about 25,000 PSI on flex mod. And then PMC 705, that's, we call it our ultra high melt strength product. 310 PSI, 310,000 PSI on the flex mod. And it's really for those parts where that need a little more stiffness, a little more strength to the sag, need to take a little bit more of a deep draw or some features. Like I said, all of those are can be extruded alone, or for properties, we can extrude a cap over them. Our Premier cap line is relatively new. So we obviously have a standard high gloss cap, but we developed the Premier cap. It's low, mid, or high gloss options. And it kind of how it came about to address the need of a field whitening phenomenon that was happening with TPOs. So you can see that light tower, the green there, it looks like a weathering failure. It looks whitened from being outside. It's not the bright green anymore. Seemed to only be happening after thermoforming. And it, like I said, it looks like a weathering failure. But it, you know, we embarked on a long project to figure out what it was because it didn't make sense. We had UV in there. These things were weatherable. They were using color fast pigments. We learned a lot and kind of found out that the root cause wasn't really truly weathering. The properties were there. It was just a surface phenomenon, happened post-forming, and it really was just on the surface where some of the mineral fillers at the surface were really being locally enhanced, where there were just more of them. So we came up with the Premier cap line, which solves that surface issue. So you can see off to the right, we did post-forming weathering on standard, and then on the Premier cap line, and the Premier cap held up. It didn't show that same whitening phenomenon. So that's where it started out, just to solve that issue. From there, we developed different gloss options. The high gloss is probably the most popular option. We also have a low gloss and just a standard. They also were developed for increased scratch and mar, especially in the high gloss product. That was one of our customers' major issues with the high gloss, is that it would scratch a little easy to mar, especially when it was hot. So you're taking these parts off the former, going over to do some secondary processing and marring them up before shipping. So the Premier cap options are good for scratch and mar. They kind of help that a little bit, so it's easier to handle the parts and get them to the customer looking great. Vibrant colors, fully capable. The slide I showed you earlier was Premier cap against the fiberglass. It is regrind compatible as well, and we can put any of our core materials underneath it. So again, we like to think of the cap materials for aesthetics, and then our core materials are there for the properties. I want high melt strength, I want high stiffness, I want FR, whatever that is. So just some of the testing that we went through as we were working on the scratch and mar. Premier cap 1755, so it's the high gloss product. We have a small Gardner scratch. So when you think of scratch styling, it's a stylus, so it's a point contact. Think your fingernail. I'm going to scratch something with my fingernail. Same kind of thing, just a little more controlled. You can see off to the far left there is an acrylic. That's kind of the gold standard for scratch, as well as for MAR. We tested the Premier Cap as well as standard high gloss TPO, and the Premier Cap performed nearly as good as the DR. So we were pretty happy with that. MAR, it's basically more of a rub than a point. So it's a sort of an abrasion. And it's 10 strokes with a specific type of cloth, and you measure gloss before and after and compare. So again, the acrylic is the gold standard for Croc-Mar. You can barely see off to the right that it was ever even rubbed. The standard high gloss, there's a big white streak down the middle. It's pretty obvious, but you can see from the data that the Premier Cap performed very well. Still not quite up to DR, but significantly better as far as amount of gloss lost compared to standard high gloss. So one of the major reasons, and a lot of people count TPO out, is stiffness. Be it an arm on a console that's maybe a little too floppy feeling, or something that has to be close to a part that gets hot. We see people say, no, I don't want to talk about TPO for that because of that reason. There are grades out there for that. They're becoming a little more popular now. We have two here at PMC. We have PMC 802. So that's a high mineral filled TPO. It takes your flex mod up to 570,000 PSI. Remember your high melt strength. So the highest melt strength grade before getting into these high stiffness grades was 310,000 PSI. It takes the HDT up to around 240. I've seen it be used near parts that get hotter just for shorter amounts of time. It's not like it's gonna melt at 240, it just starts to deform. So we've been talking about that one a lot. The benefit with PMC 802 is aesthetics. So it can be used in parts you're going to have to look at. It forms pretty well. PMC 815, if you need a little bit more heat, is the next level up. It's a glass filled TPO. It's short glass filled, and it gets your HDT up to 300 degrees. So we see a lot of fan shrouds in 815. It's close to some engine components, parts that get hot. It's also really stiff to the, stiff feel. 580,000 PSI on the flex mod. The one consideration with it is the rippling. So it kind of thins a little unevenly with the glass. So you can see in that bottom right-hand corner, it's not the prettiest part. It's got a little bit of wrinkles to it. So if it's a really aesthetic part, you've got a traditional positive tool, you might have to have that as a concern. We like to say put a texture on it, it helps, or pressure form it. So that top part, that black part is the PMC 815. It's glass filled. As you can see, it looks very good pressure formed. So it gets you that heat. It just requires a little more effort on the aesthetic side. So we, PMC, a lot of our innovation is focused on what our customers' feedback is on our current products and where we're missing the mark. So the, Premier Cap came out of the field whitening issue. Complaints about stiffness, we start to look at high stiffness grades. One of the major drawbacks of a TPO is that it's difficult to bond, it's difficult to paint. Low surface energy means nothing wants to stick to it. So coming out of that, our newest product line is Ontex. It's our Ontex 8000 series, and it solved that problem. It's directly bondable, directly paintable. So it's a film type of lamination process, and it allows for direct bonding and direct painting with no surface treatment. Actually, if you sand it, that would be negative because it removes that capability. So you can use common adhesive. So one of the major complaints, you can glue TPO, you can paint it. It just takes a lot of effort. You're putting a lot of surface treatment. There's primers The adhesives are expensive. You could use regular ABS adhesives. We have people painting it. So there's none of that extra work. We've seen, it's relatively new, but we've seen it used a couple different ways. We can use the film on the A surface. We can put it on the B surface or both. So we see people A surface bonding for paint, B surface for gluing, or both. You're going to paint it on one side, glue it to another part, glue it to metal on the other side. We found it doesn't stick, at least to aluminum tooling. That's what most people are using right now. So doesn't stick to that, which is good. Compatible with any of the core materials. So you can still get all your properties, your high melt strengths, high stiffness materials. You can put a low gloss cap, high stiffness, and then bond, any combination. And we can put regrind back in. We watch usage a little bit on this one. We say up to 20% back. We did do some testing. We had some testing done with some outside suppliers just to make sure it was passing muster. One of the automotive grade tests for paint adhesion is this crosshatch test. We looked at red, we looked at a silver, and you can see even after thermal cycling fully from -40 to 80 C, performed very, very well. So we got good adhesion on the paint. And then we also did a lap shear test for bond strength, where we made these little plaques. We bonded ABS as a control, as well as the TPO with Ontex. And we kind of took a poll of some of our main thermoforming customers and asked, what do you use to glue ABS? What do you use to glue ABS to things? And a popular one is that MA300 from the Plexus. So that's what we used. And you can see the Ontex performed just as well as the ABS. So we were very happy with that. Also, the standard TPO, you can see it didn't stick at all, which is what we would expect, but just to make sure. So we tested those and everything looked pretty good from that point. So that's a nice option, especially when you're looking at multiple sheet systems or parts that need reinforcement, especially, maybe there's some sort of attachments or something where you need it to be a little stiffer, so you need to reinforce on the backside. We see a lot of that, or just an easier way to paint. Exultra is kind of the last of the series of the options. It's our answer to, it's one of our older product lines, but it answers needing a soft touch feel. So that kind of high coefficient of friction, soft feel. It's pretty popular in consoles, interior parts, where you kind of want that soft feel without going to like a hand wrap ABS part. So it's a TPE cap, co-extruded over TPO, 90 Shore A. So we have tried softer. They're extrudable. They're out there, but the softer you make a TPO, the more it's gonna suffer scratch and mar. So we found 90 Shore A's kind of gives you that soft touch feel and some scratch and mar resistance. Used a lot in marine, so it is outdoor weatherable. Good chemical resistance. We see, like I said, a lot of marine dashboards, so that's a pretty heavy outdoor use. Very low gloss, so interior parts pretty popular. Definitely less than 4%. It's a true matte look. And we use regrind in that every day as well. So we put it over any of our core grades. So the high melt strength, glass filled, high stiffness, you can have any of those core properties and then give it this soft touch feel. So you can kind of see in the lower right, it also takes texture really well in a mold. So we do some smooth and some really light textures. So you can get that detailing, seams or any kind of fixtures you want to add into that mold. So thanks for sitting through my spiel for a little while. I'm gonna turn it over to Cody. They've got several case studies that they want to talk about where they've used TPO to solve some issues with other materials.
Sam, thank you so much. And don't worry, everybody, Sam will be back. So one quick announcement that I missed at the beginning of the webinar is we will be having a Q&A session following the end of the presentation. So we've had some people submitting questions already that have been really good, and I appreciate that. Anyone else, you can submit questions at any time. There's a little like a speech bubble with a question mark on your toolbar. Just go ahead and click that, put your question in. We'll get to it right at the end. So one of the case studies that we want to look at today is this telecommunications box. And now this box was originally designed by our customer in a sheet metal housing. They just, not knowing anything about really the process, they thought sheet metal was the way to go. And a lot of the roadblocks that they were hitting during that design was finding the geometry that they wanted, not only the shape of the box, but the vents that you see in this box. Vents are on the front, the back, and the top. These are going to be very costly to design into a sheet metal enclosure. So they were having issues with their design. They were having issues with, it is a telecommunication box, and the metal enclosure was essentially creating a Faraday cage around their electronics and hampering their ability to broadcast. So it wasn't going to function with their equipment the way they wanted to see that. And also they were worried about needing to post-process this. With all of the bending, welding, and grinding that would take place to make this a sheet metal box, it was going to need to be either painted or powder coated. They were looking at powder coating because it's going to be an outdoor application, so they didn't want it to, they didn't want paint to chip and rust off. And so that was one of the things that they were looking at, and they were worried about what type of cost that would add to the program. So the TPO application that we worked through them with, we were able to help them with the design of the mold to be able to get these vents in there. So this mold, in addition to being a thermoform mold, has these actuating components inside the mold that, as the plastic would form over the mold, these actuated pieces of the mold would slide into place, creating the molded in vents that they were looking for, that didn't require any post-processing to get. The molded in color of the TPO allowed them to eliminate painting or powder coating from their process. And mainly now, and one of the biggest things for them was no longer being metal, the plastic didn't interfere with their electronic signals, and they were able to boost their signal significantly. Overall, we were seeing this finalized TPO assembly. It's a multi-part assembly with a hinge on it, coming in at roughly 30% of the price that it would have cost them out of a sheet metal. So the next slide that we'll be looking at. So here is another case study, and this one is working with a forklift manufacturer. We were producing a part for them. It's actually right behind the forks and in front of where the driver sits. There's a plastic panel, and that one was being made out of a PVC acrylic blend. And they've been using it on this forklift for many years, and all of a sudden they started they gave a version of this forklift that was going to be used inside mainly cold storage and freezer units. And what they were finding is, as these forklifts were used inside freezers, when the temperature was getting really low, the PVC acrylic was very brittle. Imagine inside of a cold storage warehouse, someone knocks into a shelf and a 30-pound frozen turkey comes flying off a shelf. It was landing on these parts and shattering them. So what we did was we were able to work with PMC and using the same molds that they already had, transfer this over to a TPO material that is, as Sam explained before, has excellent cold weather properties. And it was able to reduce all the warranty claims that they were receiving from cracking on this particular part due to the cold weather environments by around 80 to 85%. They reduced those warranty claims, so they were very happy with this transition over to the TPO. And one of the things that they were concerned with was that TPO might not meet the UL requirements that they had, but we worked with PMC to make sure we were using a proper grade of TPO that could meet the UL requirements. So here's another application for TPO, another outdoor application like the telecommunications box was, and like that telecom box, the kind of complex geometry here was going to be very expensive to achieve in sheet metal. Just the amount of processing that the sheet metal takes was causing production delays. You know, Sam mentioned a little bit on the process time of TPO versus something like fiberglass, but process time versus something like sheet metal is even smaller because you're not requiring welding, grinding, sandings, anything like that. So in addition to the process time being long in a sheet metal application, what they were finding was because this cover also incorporated some commercially available and thermoform, I'm sorry, not thermoform, but injection molded parts. The small cover over the intake vents and output fans are injection molded pieces that were incorporated into this design. So what they were finding in sheet metal is where they'd have to pop rivet those together. Actually, the environmental seal was being compromised by those pop rivets. So now the unit wasn't as sealed as it should have been, and they were getting some damage to the internal parts. So the TPO cover allowed for, again, that excellent weatherability, UV protection, so they didn't have to worry about it in outdoor applications, cold weather environments. So even on snowy days, they didn't have to worry about this unit being broken. So changing over to the thermoform TPO showed them a lot of advantages from not only reducing their lead times and cutting down on some of the production delays, but also it was easier for them to incorporate the other components that they had in their design into the thermoform design than it would have for the sheet metal. Next slide. All right. So now I'm gonna hand it back over to Stacy. She's gonna tell you a little bit about some of the ways that we actually form TPO and some of the little tips and tricks that PMC has learned along the road.
Thanks. Let's see. Oh, good. Got it. All right. Switching back and forth. I'm new to that. So like Cody said, we've been working with TPO basically since the start of PMC, so 2003. Some of you probably worked my current boss, Eric Short, so he was in on the ground floor of that. So we've learned a little bit along the way. I'm sure some of you have learned a lot as well. So just some quick tips and tricks with forming TPO. TPO, one thing, it's not a great selling point for it is it's not as easy to form as ABS. TPO is semi-crystalline, ABS is amorphous, so they're different types of flow patterns. So what does that mean? ABS, it starts to melt, and the hotter it gets, the more it melts, but it's slow. TPO, once it melts, it melts. So we say you're aiming for a core temperature range of 340 F, not surface, core temperature. And you only get 5 degrees either way. So it's not a large forming window. Some of the things that happen is, like you see in the picture on the right, your sag gets away from you. Once it starts to go, it's going. So you have to make sure it's being pulled out at the right time, at the right temperature. So it's a more precise melting point. For that reason, we usually say it's best to cycle your machine on sag. It's got to be in there 5 minutes. Well, it's going to vary a little bit. Going to vary depending on the time of year, the time of day, a lot of different things. So you've got to really make sure you're pulling it out based on how deep the sag is and just based on how quick your machine cycles. Some other issues we see a lot, we get webbing, both hot and cold webs, either too much material in an area or what we call freezing off, irregular melt thinning, where you've got kind of a hole in the wall of the part. Air entrapment, it's sticky. And then, you know, it's not very, it's not easy to orient. So like your high density polyethylene, like if I can pull it all I want down the line, here at PMC, it's not going to really give you any orientation. It just doesn't do that. And it takes up to 48 hours for total crystallization. So the parts, you know, they're a little more sensitive post-forming. So again, SAG, I highly recommend it. Cycle it on SAG, not on temperature or time. Oven control is a big one. You can get away with a lot in ABS that you can't get away with in TPO. So you can see off to the right, we recommend using an IR gun every once in a while. For one thing, they're super fun. I love ours. But look, you can see how your oven is performing. So a lot of those elements are glowing, you know, red, yellow, but you've got 3 over there at the edge that are out. Further in, you've got 3 that are maybe half on. So those are going to be cold spots, and the TPO is going to show you that. It's going to have some issues in that area. It's not going to sag evenly. We say quartz or ceramic for type of heater. We've seen CalRod work. It's a little more effort. We've never really been able to use gas or gas catalytic and get good parts. So even heating, properly functioning elements, and we always say to build a heat wall. So about 12, 16 inches from the clamp frame to the outside of the oven, which you can see here in the example profile. Do a little more heating from the B side than the A side, and that just helps protect any of your high gloss caps, low gloss caps. On the tooling side, one of the first things we try to do if you've got a really complex part and you're having trouble, just flip it upside down, put the tool on the top. That allows it to kind of come down into a bubble. When it starts to get really complex, maybe you're trying, you know, you got a lot of dead space, some big features, a snapback method might be needed. It's basically you pull a draw box and you pull a big bubble first, and it results in a lot more even wall thickness because you're stretching it first and then vacuuming it onto that tool, sort of snaps it into the shape. So a lot less webbing that way, a lot more even wall thicknesses. Again, temperature controlled aluminum. TPO takes 48 hours to fully cure. Cooling is key, just as heating is key. So being able to cool not just with fans from the outside, but evenly from the backside is a big benefit. Ceramic works too, just holds a little more heat. Epoxy wood or fiberglass, we see them very popular in prototyping and they work fine for that, but TPO is pretty sticky and it starts to eat at those tools and really tear them up. Trapped air is another concern, so smaller vacuum holes. Even at PMC, we can see the vacuum holes in some of our quality tools because they're just larger. Sealing is a big concern. TPO doesn't like to suck to the tool quite well. So you can see in that bottom right, they've got a small, what's called moat, a little seal area, and they were having trouble with definition on the edges of the part. You need a little bit more or more of a box to seal it down to that tool, especially in those shoebox type of shapes or large open shapes. Some optional equipment, cooling fixtures. Again, TPO takes 48 hours to crystallize. A lot of people use cooling fixtures to prevent warp and stress whitening. So if it's not cooling evenly, it's gonna kind of move around, and it can do that for up to 48 hours. Vacuum bleed control on or off isn't necessarily as helpful as, you know, maybe I need a little less, a little more. And then just a sag eye. Vertical's best, but bringing that sheet out of the oven at the right time saves a lot of scrap. Cooling, we say 2 seconds per thousandth for cooling and 1 second per thousandth for heating. So you can demold it around 160, but it usually needs a little more cooling past that even cooling. So that's where those cooling fixtures allow air all around the part. Get asked a fair amount about bonding and trimming, double fluted taper bits. We see a lot of water jet in the soft touch Exultra. It kind of tears on the edge. So that's what we see there. For bonding, like I said, TPO can be bonded. We see a lot of the structural adhesives from 3M, a little bit of Loctite with the polyolefin bonder. VHV tapes work really well. All of those are relatively expensive. So that's where Ontex comes into play. It's directly bondable, directly paintable without any of that. So that's also an option. Quick material comparisons, just a general purpose. So against the high melt strength TPO, we chose our PMC 700 grade. It's a little more expensive than HDPE, but you don't have to deal with the CLTE shrink of HDPE. So that's kind of that main benefit. Right now, with just the market the way it is, medium impact ABS is in that same price range as TPO at this point. The main benefits over ABS would be weatherability. ABS is not naturally weatherable. CLT is still higher than TPO with the ABS, and impact, cold weather impact is a big deal. Painted metal, we talked about multiple steps. Weight is a big one, corrosion, denting, and it can be a lot more expensive to run a paint booth. On the high glass side, Premier Cap versus acrylic, same kind of benefits as over ABS. Painted metal and gel coat fiberglass are the other high gloss options we come up against. Fiberglass, yes, it's very stiff. It's a true high gloss Class A surface. It's not as weatherable, very labor intensive, weighs a lot. And then when we talk about high stiffness or heat, it's the mineral filled and the glass filled on the TPO side. And we really end up getting stacked against the fiberglass as well as PCABS. Right now, PCABS is crazy expensive. It's crazy hard to get. Yes, it's got better scratch and mar. It's easier to bond, easier to form, but it's not as weatherable. And it's right now hard to get. So. Sorry, I kind of sped through those. I want to make sure you guys get time to ask questions and get out on time. These are just some of our available sheet textures. They're on our website as well. If you ever have any questions or anything about what materials or anything like that, there's my contact info. I'm out of PMC, so on the material side, and I'm sure Cody and the team at Productive Plastics would be more than happy to help you with any of your thermoforming design and part questions.
Sam, thank you so much. We really appreciate all the great information that you're able to share. So we've gotten some great questions coming in over the chat. Hopefully I'm going to ask you a few of those now. And again, it's not too late, so if anyone has any questions, go ahead and submit them. So I want to dive right into them so we can get everyone to lunch. Someone was asking, can you use TPO parts submerged in water?
That's a good question. It's not common, I would say, but TPO is hydrophobic, so it doesn't like water, versus an ABS, which is hydrophilic. So we have quoted it before for mostly covers on items that would be like underwater type of drilling. I don't know of any of those that really came to fruition, but it shouldn't hurt it.
Okay. Another one, someone's asking, I have a current part made out of ABS. If I wanted to transfer that to TPO, can I use the same tooling?
That's a good question. I've seen it work and I've seen it not work. It's worth a try. You already have the tool, so sampling it doesn't hurt anything. Some things we're working on a couple projects now where we're trying to do that. One of the projects, the main issue that we're seeing is TPO. Once it touches a surface, it comes out, it's hot, it touches a surface on the tool, that's where it's staying. It's not moving. So got to be careful with the shape and how the TPO, how the tool comes down into it, because once it touches off, that's the shape it is. So we get a lot of like crowning or bubbles kind of at the top, where it might require that snapback method or hanging the tool. So you might have to make some changes there. And then just what type of tooling you've got, what kind of seal, and any, some of the dead areas where you might be using a web killer now in ABS, guess what? It's going to touch off on that too. So TPO is going to try to stick to that. So you got to use caution. Sometimes you got to get a little creative, and we feel free to reach out. We do a fair amount of help on that with our customers, where we come out and do forming trials.
All right. Another one I have here is, does PMC offer an extruded TPU?
No, at this point we do not. We played in it a little bit at one point, but right now, no. We get into a TPE cap and that Exultra, and that's about as close as we get, and it's just a cap layer.
Okay. All right. Speaking of the Exultra, I have another question about that. Is can you get the Exultra with an Ontex on the B side?
Yes. Currently, no one's asked for that, but just shouldn't.
Well, at least someone did today.
So yeah, like I said, it's a relatively new product. So we haven't had that request, but there's no reason it shouldn't be able to be put on the backside. So we're doing a lot of low gloss cap and then people gluing stuff to the back. But yeah, you could do soft.
All right. What's the max amount of regrind that's allowed in TPO?
The big question. So it depends. It depends. So our standard, usually we have products that go up to 100% regrind. They're just a standard utility grade TPO. Maybe it's not a visible part. It's not a hard part. It's got a heavy texture. So we can go that thick. When you start to get into caps and you're using a high melt strength core, the more regrind that you're putting into it. Obviously, you're recycling that cap material too that doesn't quite have the melt strength. So you're going to start to see some degradation of melt strength. So some of the specialty caps, we say no more than 20%. I would say our average is around 30 to 40% regrind. And we put that all in the core of the parts. So.
Okay, one other question here. We have time for just one more question before we wrap up. And I'm not sure I understand this question 100%, but maybe you do. Are TPO parts weldable?
Weldable?
That's what I was asked.
That's a good question. I know, our sister company, SIMONA America, does a fair amount of welding, but they're mainly in the polyethylene type of space. I don't know. I would think you'd have issues with it. It's hard to bond to. That's a good question that I can look, but I'm not sure we have anybody welding it right now. A lot of gluing.
All right, then. Well, for the person who asked that question, that's one of those great technical questions that you reach out to Samantha Stacy, sorry, at PMC, and try to get a little bit more information on that and see what we can find out.
For sure.
So I really want to thank everyone today for jumping on to our webinar. I hope it was informative, and I hope that this can lead you to contacting either myself here at Productive Plastics for any part RFQs, or talking to Samantha over at PMC if you've got more questions about the TPO itself, trying to figure out what kind of melt strength you need, what kind of, what one of those TPOs is best for your application. I want everyone to be on the lookout for follow-up emails from this. We will be sending out a recording of the webinar. Included in these emails, you'll see some design guides that Productive Plastics has created, some of the things that might be able to help you in a little bit of the design of your parts, and some data sheets and other technical info on PMC products and the TPO specifically. And I believe that we will make just the presentation available as well. So if anyone wants to be able to download the presentation you saw without the webinar commentary, you'll be able to do that as well. So again, I want to thank everyone so much for jumping on today. Please reach out to myself, Cody Brewer at Productive Plastics, or Samantha Stacy at PMC with any follow-up questions that you have from today's webinar. Thank you so much, and we really appreciate you being here. Hope to see you on the next webinar that we do. Have a good day, everyone.
Thanks.